Welcome to the 2023 Mathematics Framework for California Public Schools. This framework serves as a guide and is designed to help implement the California Common Core State Standards for Mathematics, adopted in 2010 and updated last in 2013. This first chapter, Mathematics for All, Purpose, Understanding, and Connection, kicks off by emphasizing the importance of math in everyday life. It likens a society without math to a city without parks or museums, essentially missing out on the beauty and practicality of mathematical ideas. This framework is built on three key principles: focus, coherence, and rigor. These principles ensure that California students gain a deep, meaningful understanding of mathematics that connects to real-world context. The framework is primarily for teachers, as teachers have the most direct impact on students' mathematical proficiency. It also serves other educators and stakeholders involved in supporting math education, such as publishers of instructional materials. This framework lays out an approach to curriculum and instruction that harnesses and builds on students' curiosity and sense of wonder about the mathematics they see around them. Learning math is crucial because it provides tools for understanding and shaping the world. However, math can either launch students into numerous career paths or act as a gatekeeper that shuts them out. The framework seeks to ensure equity so that all students, regardless of background, have access to high-quality math education. Students learn best through active engagement, questioning, problem-solving, and reasoning. This chapter stresses the importance of creating math classrooms that foster student agency, encouraging them to see math as a tool for making sense of the world. Research shows that mathematical understanding is not confined to a single area of the brain, but involves interconnected systems that grow with use. Equity is a central framework theme. Mathematics can serve as a powerful launchpad for nearly any career or course of study. However, it can also be a gatekeeper that shuts many students out of those pathways to success. The framework acknowledges the significant racial and socioeconomic gaps in math achievement and aims to dismantle the barriers that prevent many students from succeeding. It promotes the idea that all students can achieve high levels of mathematical understanding when given the right opportunities and support. The framework advocates for teaching math through big ideas that connect to real-world problems. This approach helps students see the relevance of math in their lives and keeps them engaged. It also highlights the importance of varied instructional practices, such as collaborative problem solving and using multiple representations of mathematical concepts. Effective math instruction involves investigating the why, how, and what of math. Teachers are encouraged to design lessons that connect these elements, helping students see the coherence and purpose behind their learning. The why includes the three drivers of investigation. The how revolves around the standards for mathematical practices, and the what includes content connections. The why, how, and what guide instruction and create a coherent learning experience. Assessment is another key framework component. The framework emphasizes the need for assessments that measure focus, coherence, and rigor, ensuring that students are not just memorizing procedures, but truly understanding mathematical concepts. In conclusion, this first chapter invites educators to reimagine mathematics education, aiming for a future where all students are equipped with the mathematical knowledge and skills to thrive in their personal and professional lives. A key component of this equitable, engaging teaching is planning math teaching around big ideas. Teachers teach their grade-level big ideas by designing instruction around student investigations of intriguing, authentic problems framed by a conception of the why, how, and what of mathematics. When implemented as intended, such investigation can tap into students' curiosity and motivate students to learn focused, coherent, and rigorous math. This approach to math education is the means to both teach math effectively and make it accessible to all students. Chapter 1 sets the stage for a transformative approach to math education, one that values curiosity, relevance, and deep understanding. Welcome back. Let's dive into Chapter 2 of the California Mathematics Framework, focusing on teaching for equity and engagement. This chapter is all about creating math classrooms that support all students from transitional kindergarten through 12th grade by fostering equitable and engaging learning environments. First, let's talk about the need for greater equity and engagement. Despite efforts by California teachers, the data shows that many students, especially those from marginalized groups, are not meeting the math standards. As an example, only about 1/3 of students met or exceeded the math standards in the 2021-22 school year, with significant disparities among different student groups. So this chapter emphasizes that to bridge these gaps, systematic changes in our approach to math instruction are crucial. This chapter identifies 3 key dimensions of systematic change: an assets-based approach to instruction, active student engagement, and finally, cultural and personal relevance. So an assets-based approach really means recognizing and building on students' existing skills and cultural backgrounds. This helps to create a classroom environment where all students feel valued and capable. Active engagement involves students learning through investigation and making connections. Instead of passively listening to lectures, students actively engage with math concepts through hands-on activities, discussions, and problem solving. This approach not only makes learning more enjoyable, but also helps students develop a deeper understanding of mathematical ideas. Cultural and personal relevance is about connecting math to students' lives and experiences. By incorporating students' cultural backgrounds and interests into lessons, teachers can make math more meaningful and engaging. This approach also supports linguistic diversity, which is particularly important to a state like California with a very large population of multilingual students. So this chapter also outlines 5 components of equitable and engaging teaching. Number 1, plan teaching around the big ideas. This involves focusing on the big concepts in math and how they connect to each other rather than just isolated topics. This approach of teaching around the big ideas helps students see the bigger picture, as well as understand how different math concepts relate to one another. Number 2, use open, engaging tasks. Open tasks are problems that can be approached in multiple ways, encouraging creativity and critical thinking. These tasks involve engaging students more deeply and allow them to explore different strategies for solving problems. Number 3, teach towards social justice. This means using math lessons to address social issues and promote equity. For example, teachers might use real-world data to discuss topics like income inequality or environmental justice, helping students see the relevance of math in addressing societal challenges. Number 4, invite student questions and conjectures. Encouraging students to ask questions and make conjectures fosters a more interactive and engaging learning environment. This approach helps students develop their critical thinking skills and become more active participants in their learning. Number 5, prioritize reasoning and justification. Emphasizing the importance of reasoning and justification helps students understand the why behind mathematical concepts, not just the how. This deeper understanding promotes long-term retention and application of math skills. So in conclusion, Chapter 2 of the California Math Framework emphasizes the importance of creating equitable and engaging math classrooms. By focusing on big ideas, using open tasks, teaching towards social justice, inviting questions, and prioritizing reasoning, teachers can support all students in developing a love for math and the skills they need to succeed. Welcome to Chapter 3. Chapter 3 from the California Mathematics Framework dives into the development of number sense across the grades. This starts in transitional kindergarten all the way through high school. Number sense is all about understanding numbers intuitively and being able to use them flexibly, efficiently, and accurately. This chapter starts by highlighting how children's relationships with numbers begins even before formal education. From a young age, kids use numbers to make sense of their world, whether it's counting their toys, tracking time, or comparing who has more cookies. This early interaction with numbers sets the stage for more structured learning. So in the primary grades, TK through second grade, the focus is on organizing and counting numbers, comparing and ordering them, and learning to add and subtract. For instance, kids might use objects like blocks, counters, to visually grasp these concepts. Activities like counting collections help children count and represent numbers. This enhances their understanding through hands-on practice. All students move into grades 3 to 5. That's where they're going to extend their flexibility with numbers. This stage introduces multiplication and division. It also deepens their understanding of fractions and decimals. Here, number lines become a crucial tool, helping students visualize numerical relationships and operations. Middle school in grades 6 through 8, students begin to develop a more sophisticated understanding of ratios, rates, percents, and proportional relationships. These concepts are vital as they lead into algebra. For example, understanding how to scale a recipe up or down involves proportional thinking, which is grounded in number sense. In high school, grades 9 through 12, the emphasis shifts from seeing parallels between numbers and algebraic functions and understanding real and complex number systems. This also highlights the importance of number sense in financial literacy, preparing students for real-world applications like budgeting and managing finances. Throughout all the stages, the framework stresses the importance of teaching strategies that promote flexibility and deep understanding over rote memorization. For example, instead of just learning multiplication tables by heart, students explore different ways to break down and understand the numbers involved. This chapter also underscores the role of precise mathematical language and the need to support students' mathematical learning through literacy and language development. This is especially crucial for English learners and students with learning differences, ensuring that all students can engage with and understand mathematical concepts. So in closing, Chapter 3 of the California Math Framework provides a comprehensive guide for educators to help students build a robust and a flexible understanding of numbers, hence preparing them for both higher level math and everyday math. Let's take a look at Chapter 4 of the California Math Framework. This chapter is all about exploring, discovering, and reasoning with mathematics. The chapter delves into the heart of what makes math learning engaging and effective for students from kindergarten through high school. So let's break it down. The chapter sets the stage really by emphasizing the importance of the Standards for Mathematical Practices, or SMPs. We briefly discussed this in an earlier chapter, but the Standards for Mathematical Practice, or SMPs, is describing fostering habits of mind and interaction. These are crucial for math learning. Now, these standards are the same for all grades, kindergarten through high school. These standards encourage students to persevere in problem solving, explain their thinking, construct arguments, form a strong foundation for exploring and reasoning in math. The ultimate goal of the California Common Core State Standards for Math is to prepare students to be adept users of math in their daily lives, regardless of their chosen career paths. Proficient students are expected to engage actively with mathematical problems, experiment with solutions, adapt strategies to new challenges. And so this chapter really underscores the dual nature of the standards. The content standards, which outline the skills and knowledge specific to each grade, while the standards for mathematical practice, or SMPs, remain consistent across all grades. These are guiding students in how to interact with the math. So the SMPs are designed to instill critical habits of mind, making mathematical representations, attending to structure, reasoning through problems, habits of interactions. These are things like explaining one's thinking and engaging in discussions. So the habits are essential for deep learning and understanding of math. This chapter really highlights that by the time students graduate, they should be completely comfortable with various mathematical practices, including exploration, discovery, generalization, and justification, because again, these practices would have been in place since kindergarten. So instructional activities should be intriguing investigations that elicit curiosity and motivation. Activities like this are framed by the 3 drivers of investigation, or DIs. These are briefly mentioned in the first chapter, but we're going to go into a little bit more detail here. So the drivers of investigation, again, there's 3 DIs. That's sense making, predicting, and having an impact. The 8 SMPs provide the methods of exploration, how we're going to do it, right? The methods, while the content connections ensure coherence across grades. This approach really helps students make sense of the world, use math to understand real-world context. So this chapter goes on to describe how students' interactions with math evolves from elementary through high school. In elementary, they explore basic number concepts, place value, math relationships. Middle school, they're looking at deepening their reasoning with more abstract representations, expressions, equations. And in high school, they're equipped to handle more complex math ideas like functions, geometric relationships, and data analysis. So the chapter gives some really nice examples. It concludes by reinforcing the idea about engaging students in meaningful, authentic math concepts, helps them develop a robust understanding of math. It prepares them for academic success, but also empowers students to use math to make informed decisions in their personal and civic lives. In summary, Chapter 4 provides a really comprehensive look at how we can cultivate deep, meaningful, lasting mathematical skills for students in both their exploration and discovery, as well as their reasoning. It stresses the importance of the SMPs across all grade levels. We saw an example of the progression through the grades and thinking about how that changes, but the SMPs are really integral in creating a rich and engaging math learning experience that prepares students for the challenges and opportunities.
Chapter 5. Let's move into Chapter 5 of the California Math Framework, focusing on mathematical foundations for data science. This chapter emphasizes the critical need for data literacy and data science skills in today's data-driven world. First, the chapter defines data literacy as the ability to ask and answer real-world questions from data sets through an inquiry process, including skills like selecting, cleaning, analyzing, visualizing, critiquing, and interpreting data. It highlights that while all students should graduate with data literacy, they also need opportunities to delve deeper into science data, which builds on data literacy and incorporates advanced mathematics, statistics, and computational skills. The chapter underscores the increasing relevance of data in various sectors, from personal decisions about health and finance to understanding news and societal issues. It argues that all students should be equipped to participate in this data-driven world and highlights the growing job market for data science, making it a valuable field for the future careers. The framework outlines 3 thematic topics that support data science education across grade levels: understanding and describing variability in data, data collection, and sampling, and comparing distributions and identifying associations between variables. These topics begin with simple activities in early grades and progress to complex investigations in high school. For younger students, the focus is on basic concepts, like counting and categorizing data, while middle school students move on to exploring data distributions and relationships. High school students engage in sophisticated data analysis, including linear models and inferential statistics, preparing them for further education and careers in data science. The chapter also emphasizes the importance of equitable and inclusive instruction in data science, ensuring all students have access to these critical skills. It connects data science education to the standards for mathematical practice, showing how data science can be integrated into broader math learning to enhance problem solving and analytical skills. In conclusion, Chapter 5 of the California Math Framework highlights the essential role of data literacy and data science in modern education. By building a strong foundation in these areas, students are better prepared to navigate and thrive in a world where data is omnipresent, ensuring they have the skills needed for personal and professional success. We're exploring Chapter 6 of the California Mathematics Framework, focusing on mathematics for transitional kindergarten through grade 5. This chapter is all about helping our youngest learners investigate and connect big ideas of mathematics. The framework emphasizes a vibrant, interactive, student-centered approach to math from the very beginning. For our youngest students, math is just not about numbers, but about understanding concepts like place value, arithmetic operations, fractions, geometric shapes, properties, and measurement. These foundational skills set the stage for their success in middle school and beyond. The chapter is divided into two main sections: transitional kindergarten through grade 2 and grades 3 through 5. For the early grades, the focus is on creating meaningful math activities that nourish curiosity and develop reasoning skills. Teachers are encouraged to use a big ideas approach, organizing instruction around the clusters of standards that connect concepts across different mathematical domains. This helps students engage with the material in a way that's both meaningful and multidimensional. Mathematical investigations are key. They promote understanding, communication, and mathematics, and the development of mathematical identities. Teachers create supportive climates for these investigations by providing opportunities for mathematical discourse, encouraging students to construct arguments, make sense of others, ideas, and engage in activities that require explaining and justifying their thinking. In practice, this means math is everywhere. For example, when a teacher asks how many pencils are needed at each table, or how many minutes until lunchtime, students are engaging in math without even realizing it. These everyday questions help children see the relevance of math in their daily lives. As students progress to grades 3 through 5, the complexity of the mathematical discourse increases. They start to engage in more sophisticated tasks, exploring numbers, data, and space in ways that make them think mathematically about the world around them. Teachers use rich, open-ended activities to keep students engaged and to help them see the connections between different mathematical concepts. Equity and engagement are also critical. The framework emphasizes that all students, regardless of their background or learning abilities, should have access to rich mathematical problems that invite curiosity and allow for multiple approaches. This includes supporting English learners and students with learning disabilities by making language resources available and connecting classroom math to students and cultural backgrounds. Ultimately, the goal is to ensure that students are prepared for the next stage of their education by focusing on big ideas, fostering mathematical discourse, and providing meaningful, equitable instruction. Teachers can help students develop a deep, lasting understanding of mathematics. In conclusion of Chapter 6 of the California Mathematics Framework, remember, math is not just about numbers. It's about thinking, exploring, and connecting ideas in ways that make sense to young learners. Chapter 7 of the California Mathematics Framework focuses on middle school math education, covering grades 6 through 8. This period is crucial for solidifying foundational math concepts and fostering a positive attitude towards math. Here are the key points. Middle school math builds on elementary concepts like arithmetic operations, fractions, and geometric shapes. The chapter emphasizes the importance of engaging students with meaningful math activities to spark curiosity and develop a positive self-perception as math learners. This engagement is essential for preparing students for high school math and beyond. Middle school math is a critical time for shaping students' attitudes towards math and their self-efficacy as math learners. The experiences and guidance they receive can significantly impact their future math success, including decisions about math coursework that affect college and career opportunities. Schools must ensure that all students, including those who accelerate their learning, have a solid foundation and can close any curriculum gaps. The framework promotes a big ideas approach, presenting math as an interconnected concepts that students explore through investigation and discourse. This approach of investigating and connecting mathematical encourages active engagement, allowing students to construct and communicate mathematical arguments. Teachers play a crucial role in facilitating this process by creating a culturally and linguistically responsive classroom environment. Big ideas are central to math learning, linking various concepts into a coherent whole. Teachers engage students with these ideas through relevant and intriguing investigations. Instructional materials should focus on tasks that invite students to make sense of these ideas in authentic context, fostering a deep understanding of mathematics. 3 drivers of investigation: sense-making, predicting, and having impact. Content connections, reasoning with data, exploring changing quantities, taking wholes apart and putting parts together, and discovering shape and space, guide the instructional design. This structure ensures that students find purpose and meaning in their learning. We have discussed the 3 drivers in earlier chapters as well, and their importance within math instruction. We have also discussed the standards for mathematical practices. The 8 standards for mathematical practice, which are integral to math education, supporting students in reasoning, problem solving, and communicating their ideas. These practices are essential from the earliest grades through high school and beyond, forming the foundation for mathematical understanding. English learners face the dual challenge of learning math content and the language of instruction. The framework provides strategies to support these students, emphasizing the importance of engaging tasks that promote both language development and mathematical understanding. Small group instruction and visual or physical pairing with verbal explanations can be particularly effective. In summary, middle school math is a pivotal stage in students' educational journey. The framework aims to create engaging and supportive learning environments where all students can develop a positive identity as capable math learners. By focusing on big ideas, encouraging mathematical discourse, and supporting diverse learners, teachers can help students build a strong foundation for future success in mathematics. Chapter 8 of the California Math Framework focuses on high school mathematics, emphasizing the importance of connecting mathematical concepts to real-world applications. The chapter begins by outlining the crucial role of mathematics in high school education, stressing that students need to develop both content knowledge and practice skills to prepare for college and career success. The framework identifies three main components to drive mathematical investigation and connection. Drivers of investigation, standards for mathematical practice, and content connections. These components guide the why, how, and what of learning mathematics. The drivers of investigation motivate students by showing the relevance of math in understanding the world, predicting future events, and making impactful decisions. The standards for mathematical practice, which are consistent from kindergarten through 12th grade, focus on habits of mind such as problem solving, reasoning, and modeling. The content connections provide a structured way to explore various mathematical topics, including data reasoning, changing quantities, and geometric relationships. A significant part of the chapter is dedicated to the need for integration in high school mathematics. Integration refers to connecting different mathematical concepts and applying them to real-life situations, making math more engaging and relevant for students. This approach aligns with the goal of equitable and engaging teaching, which includes planning around big ideas. Using open tasks, teaching towards social justice, and encouraging student inquiry and reasoning. The chapter also discusses the structure of high school math pathways. Traditionally, high school math has been divided into discrete courses like algebra, geometry, and calculus. However, the framework proposes an integrated pathway that blends these subjects to create a more cohesive learning experience. This approach aims to eliminate redundancies and ensure that students can reach advanced levels of math without the pressure of early acceleration. Additionally, the framework addresses the importance of high school coursework alignment with college expectations. It outlines pathways that allow students to build a solid mathematical foundation while providing options for more specialized study in their junior and senior years. This flexibility helps cater to students' diverse interests and career aspirations. In conclusion, Chapter 8 of the California Math Framework envisions a high school math curriculum that is interconnected, relevant, and equitable. By focusing on authentic problem solving and integrating various mathematical concepts, the framework aims to prepare students for the demands of college, careers, and civic life.
Welcome back. Today, we are summarizing Chapter 9 of the California Mathematics Framework. This chapter, Structuring School Experiences for Equity and Engagement, is all about how we can structure school experiences to ensure equity and engagement in math education for every student. The chapter begins by emphasizing the importance of expanding access to rigorous mathematics for all students. With classrooms becoming increasingly diverse, it's crucial that every student, regardless of background, has the opportunity to engage with challenging math content. The chapter stresses that differences in how students learn shouldn't be seen as indicators of their math potential. Instead, all students should be encouraged to develop a deep understanding of mathematical concepts at their own pace, with the belief that everyone can achieve mathematical excellence. One major point the chapter covers is the issue of early tracking. Traditionally, students have been placed on different math pathways based on their performance at a young age, often limiting their future opportunities. This tracking system can pigeonhole students, especially those from underrepresented groups, into lower-level math classes, which can close off advanced math options later on. The chapter argues for replacing this outdated system with adaptive teaching and flexible grouping strategies. This way, students can receive instruction that meets their immediate needs while keeping advanced pathways open for them as they grow. The chapter also explores productive strategies for teaching diverse students. This includes delaying the start of separate math pathways until later grades, offering multiple points where students can accelerate if they're ready, and rethinking course pathways to make advanced math more accessible. It suggests providing additional support like co-requisite courses or summer classes so that students can strengthen their math skills without falling behind. Moreover, the chapter highlights the importance of personalized learning. By allowing students to work at their own pace, teachers can tailor instruction to meet individual needs, helping all students to succeed. This personalized approach can be supported with technology, tutoring, and small group work, ensuring that each student can engage deeply with mathematical concepts. Finally, the chapter discusses the power of multidimensional teaching. Instead of focusing on narrow, repetitive tasks, teachers are encouraged to use open-ended, big idea-driven tasks that allow students to explore math in a more meaningful way. This approach not only engages all students, but also deepens their understanding, making math more accessible and enjoyable. In conclusion, Chapter 9 of the California Mathematics Framework offers a comprehensive guide on how to create equitable and engaging math experiences for all students. By moving away from early tracking, embracing flexible and personalized learning strategies, and focusing on deep, multidimensional teaching, we can help every student find success and joy in mathematics. Welcome back. Today we're summarizing Chapter 10 of the California Mathematics Framework, supporting educators in offering equitable and engaging mathematics instruction. This chapter focuses on how we can better support educators in providing equitable and engaging math instruction. It's all about building a system that ensures that teachers have the tools, training, and support they need to succeed in their classrooms. The chapter opens by acknowledging that teaching math for equity and engagement is a rewarding yet complex task. Teachers who are committed to using innovative approaches often see their students thrive, but these methods require a shift from traditional teaching practices. Since most teachers didn't learn math in this new, engaging way, they need ongoing professional development to help them rethink their teaching strategies and adapt to new standards. The chapter outlines the importance of creating a broad system of professional learning and support for teachers. This system isn't just about one-off workshops or training sessions. It's about continuous, collaborative learning that helps teachers improve their practices over time. Administrators, teacher leaders, and even community members all play a role in the system, working together to support teachers and ultimately students. Effective professional learning is grounded in a few key priorities. First, it should align with the vision of mathematics as a vibrant, interconnected, and creative field. Teachers should focus on big ideas, use open tasks, and center their instruction around reasoning and problem solving. Professional learning should also be content focused, meaning it should deepen teachers' understanding of mathematical concepts and how to teach them. Another crucial aspect is that professional learning should be active and collaborative. Teachers benefit most when they can engage in the same kinds of inquiry and problem solving that they are expecting to bring into their classrooms. Collaboration with peers is also vital as it allows teachers to share ideas, learn from each other, and create a supportive community. The chapter emphasizes that professional learning should be a continuous process throughout a teacher's career, from preparation and induction to ongoing development. For new teachers, this means providing strong induction programs that pair them with experienced mentors and give them access to the resources that they need. For experienced teachers, it's about offering regular, structured opportunities for learning that are directly connected to their classroom practice. Several models for professional development are highlighted in this chapter, including lesson study, coaching, and professional learning communities called PLCs. Lesson study in particular is praised for its effectiveness. In this model, teachers collaboratively plan, observe, and refine lessons, which helps them deeply understand both the content they are teaching and their students' thinking. Coaching is also important, especially when it's part of a broader professional learning strategy that includes collaborative inquiry and reflection. The chapter also discusses the importance of developing teacher leadership. Teachers who take on leadership roles, whether as mentors, department chairs, or instructional coaches, play a crucial role in spreading effective practices throughout a school or district. To support these leaders, schools need to provide targeted professional learning that helps them develop the skills that they need to guide their colleagues and improve instruction on a larger scale. Administrators have a key role in fostering a culture of continuous improvement. They can support teachers by providing time for collaboration, ensuring access to resources, and engaging in regular conversations about instructional practices. The chapter also highlights the importance of involving parents and families in the learning process. By educating parents about modern math instruction and involving them in their children's learning, schools can create a more supportive environment for students. In summary, Chapter 10 of the California Mathematics Framework lays out a comprehensive plan for supporting educators in delivering high-quality, equitable math instruction. By building a strong system of professional learning, fostering teacher leadership, and engaging the entire school community, we can ensure that all students have the opportunity to succeed in mathematics. Welcome back. Today we're summarizing Chapter 11, Technology and Distance Learning in the Teaching of Mathematics. This chapter dives into the role of technology and distance learning in teaching math. This chapter is particularly relevant in today's educational landscape where technology is becoming an integral part of the classroom, whether in person or online. The chapter starts by emphasizing that the primary purpose of technology in math education is to support instructional goals. It's not just about using the latest gadgets or software, but about enhancing how students learn math content and practice mathematical thinking. The framework encourages using technology to create interactive experiences that make math more engaging and accessible to all students. One of the key concepts introduced is the Technological Pedagogical Content Knowledge Framework, or known as TPACK. This model highlights the importance of teachers integrating their knowledge of mathematics, teaching strategies, and technology to create meaningful learning experiences. The idea is that effective use of technology in the classroom requires a blend of these three areas of expertise, ensuring that technology enhances rather than detracts from the learning process. The chapter outlines three guiding principles for effectively incorporating technology into math education. Number one, the strategic use of technology. Technology should be used thoughtfully and intentionally to facilitate powerful math learning. It's important to ensure that technology supports the lesson's objectives rather than becoming the focus of the lesson itself. For example, using graphing software like GeoGebra can help students visualize complex mathematical concepts that would be difficult to grasp through traditional methods alone. Number two, support for teachers. Introducing new technology requires changes in teaching practices and ongoing support for educators. Professional development and collaborative learning opportunities are crucial for helping teachers integrate technology effectively into their instruction. Number three, accessibility for all students. Technology should be used to promote equity in the classroom, ensuring that all students, regardless of background, have access to the tools and resources they need to succeed. This includes considering the digital divide and providing necessary support for students who may have limited access to technology at home. The chapter also addresses the shift towards distance learning, particularly in light of recent global events. It discusses how well-designed online or blended instruction can be just as effective, if not more so, than traditional in-class learning. Key elements of successful distance learning include combining synchronous or real-time and asynchronous or self-paced instruction, providing frequent, meaningful interactions, and using interactive materials that engage students deeply with the content. Preparing families and staff for distance learning is another crucial aspect. The chapter recommends offering training and support to help them navigate new technologies and online platforms. This ensures that students, parents, and teachers are all on the same page and can effectively participate in the learning process. In conclusion, Chapter 11 of the California Mathematics Framework highlights the transformative potential of technology in math education. By strategically integrating technology, providing robust support for teachers, and ensuring equitable access for all students, we can enhance the learning experience and better prepare students for the challenges of the future. Welcome back. Today we are summarizing Chapter 12 of the California Mathematics Framework, focusing on mathematics assessment in the 21st century. This chapter dives into the evolving landscape of how we assess students in mathematics and the shift from traditional rote tests to more meaningful, multidimensional assessments. The chapter begins by emphasizing that math assessments are no longer just about testing students' ability to memorize facts and apply formulas. Today, the goal is to measure a student's conceptual understanding, problem-solving capacity, and evidence-based reasoning. This transition reflects how modern math instruction focuses on big ideas and real-world applications, and the assessments must align with these principles. A significant part of the chapter distinguishes between the two main types of assessments, formative and summative. Formative assessments are ongoing and designed to give teachers and students immediate feedback. These assessments help guide day-to-day instruction, allowing teachers to adjust their lessons based on student progress. The emphasis here is on learning and growth. Examples include rubrics, self and peer assessments, and teacher feedback. Summative assessments, on the other hand, are typically given at the end of a unit or course to measure overall achievement. These are more formal, like end-of-year exams, but can still incorporate more dynamic forms of evaluation than traditional tests, such as projects and portfolios. The chapter also encourages the use of rubrics as a key tool in both formative and summative assessments. Rubrics give students a clear understanding of the expectations and success criteria. They also help students reflect on their own work and make improvements. In line with modern teaching practices, the framework suggests shifting towards mastery-based assessment, where students are graded based on their understanding of core concepts rather than on a point system. This approach promotes growth and encourages students to view learning as a continuous process. Equity is a major theme throughout the chapter. The framework emphasizes that assessments should be inclusive of all learners, particularly English learners and students with diverse cultural backgrounds. It highlights the importance of designing assessments that allow for multiple ways to demonstrate understanding, whether through writing, speaking, drawing, or using models. This ensures that all students can show their strengths. Another key point is the recommendation to move away from timed tests, which often induce anxiety, particularly for young learners. Research suggests that timed tests can create math anxiety, which hampers students' ability to perform well. Instead, the framework proposes alternative methods for building fluency, such as using conceptual and visual activities that encourage understanding without the pressure of speed. Incorporating technology into assessments is another focus. Digital platforms can offer interactive ways for students to engage with math problems and receive immediate feedback. The use of computer-based testing, like the Smarter Balance Assessment, helps assess students' skills in a more dynamic, adaptive way. These assessments adjust the difficulty of questions based on the students' responses, providing a more accurate measure of their abilities. In conclusion, Chapter 12 of the California Mathematics Framework advocates for a holistic, student-centered approach to math assessment. By using formative assessments, rubrics, mastery-based grading, and inclusive practices, we can support students in developing a deeper, more meaningful understanding of mathematics. This shift not only promotes equity, but also helps create a more engaging and less stressful learning environment for all students.
The final chapter of the California Mathematics Framework, Chapter 13, provides comprehensive guidance for publishers on developing high-quality instructional materials that align with the California Common Core state standards. This chapter, Instructional Materials to Support Equitable and Engaging Learning of the California Common Core State Standards for Mathematics, is crucial for publishers because it outlines the expectations and the criteria for materials that support equitable and engaging learning experiences for all students. This is essentially our rubric as publishers of instructional materials and what the reviewers will utilize to review and recommend our program. The criteria is organized into 5 categories. These categories are used for kindergarten through 8th grade in the evaluation of instructional materials. It is important to note that other content areas also share the similar category structure for review. All program reviews begin with the content standards. This is Category 1, to ensure the most important burden is met, that the program follows and adheres to each and every grade level standard. Let's look at each category a bit closer to understand what is required by the framework and to be included with any new math program. Category 1, Mathematics Content and Alignment with the California Common Core State Standards for Mathematics. This is the most important piece to the evaluation, the gatekeeper. If Category 1, alignment to each and every standard is not met, the other categories will not even be reviewed. Alignment to the standards is critical. This also takes a huge burden off of us. Once recommended, we can confidently say that all of our grade levels are 100% aligned to the Common Core standards, including the environmental principles and concepts specific for California. It is important that the program include clear learning objectives, instructional strategies, and include assessment tools that reflect the standards. It is also noted in this category that programs should be consistent with the full framework, including all the ideas and instructional guidance put forth in the earlier chapters. Category 2, Program Organization. This category ensures that instructional materials are aligned with the standards and support the progression of mathematical concepts across grade levels. The big ideas should be front and center and fully integrated into instruction. Materials are designed for students and teachers to spend the large majority of their time on mathematical investigations that are addressing the big ideas of that grade. In fact, the grade level standards, the big ideas, and the standards for mathematical practices should all be explicitly stated in the student editions. Intervention components, if included with the program submission, must be designed to help teachers respond to students' progress in math with opportunities to reclaim missed concepts from prior grades. They should also include or give growth mindset messages and communicate the message that all students can be successful in math. Category 3, Assessment. Student and teacher materials should include formative assessments to provide multiple methods for assessing student understanding that can help to inform instruction. Examples listed include graphic organizers, observations, interviews, journals, portfolios, and others. Student and teacher materials should also include summative assessments to provide multiple methods of assessing what students have learned and are able to do. These include examples such as selected response, constructed response, real-world problems, performance tasks, and open-ended questions. Assessment should integrate math content and the language needed to participate in the standards for mathematical practice, while at each grade level, instructional materials should also provide assessment practices necessary for all students to be prepared for a higher mathematics instruction. Suggestions include entry-level, diagnostics, formative, interim, skill-based, and summative. Teacher and student materials should also include curriculum-embedded assessments that permit teachers to scaffold student learning. Materials for teachers should also provide guidance for giving diagnostic feedback. Category 4, Access and Equity. Instructional materials must be designed to meet the diverse needs of California's student population. This includes English learners and students with disabilities or those from various cultural backgrounds. The materials should also provide entry points and pathways for students to access and engage with the math content. It should include differentiation strategies mentioned and noted in the framework, including suggestions for supporting advanced learners. Materials should also include strategies to help students who have not yet achieved grade level proficiency in reading, writing, speaking, and listening, and academic English to help them better understand the math content and practices. And finally, the visual design of materials should not distract from the math, but instead serve to support students in engaging thoughtfully. Category 5, Instructional Planning and Support. The program should include a teacher's edition that explains the role of the grade level math concepts in the context of overall math curriculum for all grades K through 12. Teacher support should also include curriculum guides, lesson plans or support, and answer keys where appropriate. Materials should provide teachers with guidance that includes suggestions for how to utilize and implement student and student ancillary materials, including specific attention to engaging students to guide them on their mathematics development journey. Materials should make use of concrete representations This should include manipulatives, audiovisual, multimedia, and interactive technology resources that all support the instruction and implementation of the Common Core state standards. This should include clear instruction and guidance for their use for both students and teachers. When materials integrate technology, such as interactive tools or virtual manipulatives, they should all do so in ways that engage students in applying the standards. Optional homework activities, if included with the program submission, should extend and reinforce classroom instruction and provide additional practice of math content, practices, and applications that have been taught. Materials should provide examples of student work and representation of possible student strategies in an effort to orient teachers to student thinking and help teachers make sense of, elicit, and respond to student thinking. Specific strategies to support students in developing the language skills needed to meet the mathematical learning and language objectives should be explicit and clearly associated with the instruction and assessment. Finally, teacher guidance should also contain explanations and examples of mathematics concepts. In conclusion, Chapter 13 emphasizes the importance of creating instructional materials that are equitable, engaging, and that are aligned with the California Common State Standards for Mathematics. By following these guidelines, it ensures that publishers can develop resources that support high-quality math education for all students in California.